So, what do we have in front of us? You'll mostly be going through your handouts first, which will be introducing the different Eurocodes. So we'll go through Eurocode 0, 1 and 2. I'll introduce all of the national annex that also apply to that. Where we can, we'll start sort of doing some calcs. I don't think we'll do much today. And there, so I'll sort of tell you where we are in terms of the handout. The extracts, just keep them sort of to the side at the moment. It is worth bringing both booklets with you a little bit later on when we start doing some calculations. I'll be doing some calcs on there. I'll be telling you to jump to a particular clause, and you'll realise how confusing this topic is. The difficult part is to be able to jump around the Eurocodes and know exactly where you've got to go. There's a lot of repetition in all of them. In terms of my introduction to this topic, this is the first evidence of structural design that they found. So this is about 2,000 years before the birth of Christ. So if you build a house and it falls and kills somebody, then the builder should be put to death. So that would that be you? You'd be classed as the designer. But yeah, or if it kills the son of the owner, then the son of that builder should be put to death. So if you want to retain your family and slaves, then you've got to make sure that you design your house well. So they were developed over sort of 25 years, and the whole idea is that by 2010, all of the UK was meant to be adopting them. That was changed to 2014. Has anybody used Eurocodes at all in their company or seen them? All right, so you two can put me right. The Eurocodes were released by the BSI now. First, you got the European Committee for Standardisation, CEN, worked with the British Standards Institute. They're the ones who produced the British standards. So they're working together, produced something called the National Annex, which you'll find is our Britishness side to the Eurocodes. There's a little bit of modifying British standards, so we've possibly got rid of some, and those that are going to be remaining, they were adapted to suit the Eurocode. Then at some point they were saying, okay, well, 2014 we'll stop the British standards and we'll start using the Eurocodes. What you found is that people wanted to continue using the British standards and didn't want to adopt the Eurocodes. You find that those who work with public bodies, they had a requirement to work to certain regulations, so therefore they had to adopt it. But you find that the private sort of structural engineers who work for private owners, there's no need to adopt them, so they weren't taking them on board. Like I read in February 2010 that this is when the Eurocodes were meant to have been adopted, that 2/3 of engineers weren't ready for them. It was costing about £16,000 to train each engineer to use the Eurocodes, which was a no to a lot of companies. And when we were supposed to have adopted them, we found that 84% of companies hadn't adopted, and a lot of them just didn't know the impact that it was going to have on their company, the way that they were working, and also the impact on the structures that they had designed. Now, the aim behind the Eurocodes was to try and bring together a family of all of the codes, rather than people producing sort of individual codes, different companies. Hopefully bring together the mechanical, electrical, instrumentation, civil engineers, structures together. Tried to bring together Europe, and Chandra mentioned that you've got the European countries who've adopted it, and if we want to work in Europe, then we should be working to these codes. You've mentioned about Australia are thinking of taking on board. You've got Hong Kong. The other sort of bigger sort of group is the American codes, and you find that there's some places take on board the American codes, some take on board the Eurocode. In terms of removing barriers to trade, it'd be nice if we could work in another country. We couldn't take our British standard codes across there, so that's why we've adopted to take these Eurocodes on board. Chandra's shown you the different codes that there are. I'll go through them. So at the top, the foundational Eurocode that we have is, they call it Eurocode. It was produced in 1990, and then you find that Eurocode 1 was produced in 1991, and Eurocode 2 was 1992. These are the years that they were produced. It just so happens that it coincides with the number of these Eurocodes. It's not like a standard that whichever year it is, that's the number that it is. But Eurocode 1990, they call that Eurocode 0 unofficially. That's the basis of structural design. You've got Eurocode 1, that's where we start looking at the loading, and then once we've figured out what the loading is, then we apply that to whatever structure we're designing in the material. And we'll be looking at Eurocode 2 concrete, and Chandra will be taking over me about week 5, continuing with concrete. Chandra will also be covering steel and maybe covering masonry within there. Your extracts, some of you might have Eurocode 6 in for masonry. You won't be using that, you've just got that. You can rip the pages out or just leave the booklet as is. Some of you have just got Eurocode 0, 1 and 2. So that's all we need for this module for what we're covering. Our building, it rests on the ground, so you'll be doing some Eurocode 7, probably with Steve Bloomer in another class. Every country's got the Eurocode document, and you've got extracts from that. And so in terms of this image here, it's saying that D is the main text, but every country has its own national annex to conform the Eurocode to the way that they want to do their design. And you find that different countries have different factors of safety, individual rules, and they all go in the national annex. They have the national annex at the back in all of the Eurocode descriptions, but everybody puts the national annex at the front because everybody refers to that mostly rather than the Eurocode. So in the national annex, all of these little UK things are called national determined parameters, or NDPs, and the UK is allowed to make some changes as long as it doesn't impact on the overall Eurocode. So you can't have a national determined parameter say don't read the Eurocode. So if I'm just going to look at my extracts right now, so what we've got Eurocode 0, 1, then 2. So firstly, I give you the national annex for Eurocode 0, and then we flick over a couple of pages, and then we might have a green page, and that tells you that you're now in the Eurocode 0. And then as we flick through to the next sort of green page, we've got the national annex for Eurocode 1, and then we have Eurocode 1, the actual main body of the text. So we'll get more into this when we start sort of doing some calcs. But if you were reading the Eurocode, such as this page here, so this is Eurocode 2 on page 34, which you don't have to go to now. But in Eurocode 2, so if you're writing your calcs, you put EC2, and then there'd be a clause 3.1.6. So we're reading through, blah, 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 blah. So we're going to design the compressive and tensile strength of concrete. So it's EC2, so we're talking about concrete. And we've got this formula here. FCD is alpha CC FCK over gamma C. So you need to know a little bit of Greek, and a little bit later on when you scan through you realise that you've got a page of Greek alphabet and how to pronounce it. And so if we were going to work with this formula here, so this is the design strength. So we've got the strength of the concrete, C. The design strength of the concrete is the actual strength of the concrete times by this alpha CC and divide by gamma C, and then you've got a bit of a description. So you'll find that gamma C is the partial safety factor for the concrete, and it'll say jump to clause 2.4.2.4. And what you'll find is that when you have your material, your concrete, if you choose a C35 concrete, it's a concrete that is 35 newtons per millimetre squared in terms of strength, but we can't rely upon that. If we had made a batch of the same concrete all the time, we can't always rely that this concrete is going to be 35, so we divide it by a safety factor, and that's the material that we design with. And then you've got this other alpha CC, where because we test our concrete within 28 days, like how does that relate to a concrete structure that's been around 100 years? So they've also got this factor alpha CC, and what are the values of these? So we know where to go for gamma C. We go to that clause, and it says alpha CC is blah, blah, blah. Note the value of alpha CC for use in a country should lie in between 0.8 and 1.0. So they don't have to do decimal points in Europe. So you find that wherever there's a comma, it's a decimal point. And so it should lie in between 0.8 and 1, and you can find that in your national annex. The recommended value is 1. Eurocode basis of structural design. So we'll introduce this Eurocode. We'll take up the interesting bits, and then we'll see how we can apply them. So again, you don't refer to it much because a lot of it is repeated in the Eurocode 1 and the Eurocode 2, so you won't use it a lot. So this provides comprehensive information and guidance for all of the Eurocode. It's the foundation for all of them, and it's looking at the principles and requirements for safety and serviceability. You'll find that you'll mostly use it for safety factor values. There's a couple of tables, but you'll mostly be getting that from the national annex. Here's a contents page. So you're sort of in your handout, you're round about sort of page 4. We won't go through everything. If you go onto the construction information service, you can print out the whole Eurocode. If you just go via the British Standards Institute website, you'll probably have to pay for the Eurocode. But if you go via the library, which is that lis.tees.ac.uk, if you go to subject guides, and if you go to like civil engineering, then I think it's under journals, and that's where you've got the electronic databases. So that's where you get access to the ICE journals and the iStructE journals. So you can get all of them for free. And also you have this construction information service. Probably mentioned this in the first year, but every company doesn't have a library with books. They might have a library with some books, but books go out of date, and anything that's important, you need to make sure that you have the latest version. So you're not really meant to print things out. you're always meant to be working with the latest document. So from here, you've got loads of guides, and you can pick off like the whole Eurocode note, all, I don't know, 200 pages of it. I've given you about 6 pages of it, and you can have a bit of a read through. If you're a part-timer and you're at work, and you want to print the whole thing out, it will fill like a couple of Archiver files. I've given you an extract version. Can I ask that you use my extracts? Because since I printed out the Eurocode, it's changed a couple of times. So so some of the values and some of the pages have changed. So if you can just stick with what I've given you. However, if you want to read the Eurocode, you can get them all via the Construction Information Service. I don't recommend you get any books for what I'm covering. I think Chandra may ask you to get Eurocode, because that covers concrete, steel and brickwork. In producing my material, I use some Thomas Telford notes, and I also use a book by Mosley, a blue book, which there's some copies in the library. A structure should be designed and executed in such a way that it will, during its intended life, with appropriate degrees of reliability, sustain all actions. Now you realise that the word loads, we use the word actions with the Eurocode, so it needs to sustain all the loads and influences that are likely to occur during execution and use. So that's the design and the use of the building, and it should remain fit for use for which it's required, which, yeah, it seems obvious. So it shall be designed to have adequate stability, structural resistance, serviceability and durability. Now that's quoting direct from the Eurocode note. No, that's Eurocode note clause 2.1. So a lot of it's making sense, you know. Select a safe structure, consider all potential damage, and tie the whole thing together so that it lasts. How long is it going to last for? Eurocode note 2.3, 1, table 2.1 is what you write in the references when you write the code. We design buildings so that they last 50 years. We design bridges so that they last 120 years. So this is what you're doing. I think we're on page 5 of the handout, if you're following through there. Principles are statements and definitions for which there is no alternative. And you'll find that a lot of times you've got the verb you shall sort of do it, or you must do it. And then you've got the application rules. Now, have I got an example there? No, if I flick back to our page earlier, so what we have in Eurocode 2.3.1.6.1p, where you have a P, that's a principle. So when you come and do some design and you're reading through, you must abide by the P's. When there's no P, that's an application rule, so you can choose to ignore it. But read it all. So that's principles and rules. And then I've already mentioned about, note that wherever you see a comma, that's a decimal point. To the annoyance of all AutoCAD technicians, I don't know if you know, but whenever we did a section like this, our main axis was XX and our secondary was YY, and going through was ZZ, where Eurocode, the main axis is YY, the secondary is ZZ, and going through is XX. Doesn't really affect what you're doing in terms of the assignment, but that annoys a lot of people who do sort of CAD work. Then we've got our sort of Greek alphabet, and then we've got some symbols and abbreviations. So if you ever find that you have a symbol and you want to have it get an appreciation of what it is. Like for example, we've got ASW minimum. A is our area. You've got minimum cross-sectional area of shear reinforcement. So the limit state is a state beyond which the structure no longer fulfills the relevant design criteria. And he mentioned two different types, and I've got a picture to show this. When you see like sort of pictures like this, remember the software Calcrete? When you go in the IT labs, you can download Calcrete. If you search for Calcrete, so I think that's it, computer aided learning for concrete. Within there, it gives you some background on how concrete's used on site. Within here, it's got a number of modules on how to design concrete structures, beams, and so if you want to find somewhere else where you can sort of learn about this topic with lots of nice colourful pictures, you can download that software. I think it's 76 megabytes, and you can run it quite easy from your USB stick. But we talked about limit state. He talked about limit state design. So you've got your ultimate limit state design. So this is where you're looking at the safety of the people, where the whole thing's collapsing, and you'll find that there's factors of safety that you apply for that. And then after that, you've got your serviceability limit states, which we care about in the UK. Some countries don't consider things, but that's where this one here is where you're looking at the comfort of people and the appearance of construction works. Now what you'll find when you come to do your design, when you come to design a beam, you'll design for strength, bending, you'll design for shear, and then you have to design it for how much it's going to deflect. And the deflection calcs, there's a lot of them, and it's annoying when you've done your design and it's fine and bending and fine and shear, and then you go through all the deflection calcs and it fails, and so therefore you've got to go back and start again and go through. It's awesome if you've got a piece of software like TEDS, which is expensive and we couldn't get the university to buy it. But these things here give you different factors of safety to consider for your loads. That's what we do in terms of our structural mechanics. When we come to do the design, this is when you've got to start considering all the factors of safety. In terms of factor of safety, you realise that you've got your ultimate limit state and your serviceability limit state, and then it goes into even more categorizations to add more values for factors of safety. For example, if we looked at ultimate limit state, that's split into 4 different types of categories. You've got your EQU, where that's whenever you're looking at something in terms of equilibrium. So if you were designing a retaining wall and you were wondering whether is it going to rotate around, then you would use the factors of safety in the equilibrium area, and you'll find that there's a table just for that. You've got geo, so where this is touching the ground, you'll be using factors of safety from this table for that. We mostly use stru for structure. We might do an example with equilibrium. And then fat, that's to do with fatigue. So if you've got like a wind thing and that's like vibrating, or you've got an offshore rig where you've got all the wind and waves all pushing against the piles, and you end up getting a lot of fatigue issues, or these might be cables for a bridge, then you use the factors of safety for the ultimate limit state, fat. Hopefully by the time when we do some calcs, Some of this stuff that I'm all saying just all makes sense. I haven't mentioned design situations because all of these are split into 4 different. There's persistent design, transient design, accidental, and seismic, and but I just skip past all of that.